Hi everyone, welcome to the course on social network analysis. My name is Tanmay Chakraborty and I will be the instructor of this course. This is going to be a very fun course because of the obvious reason. As the name suggests, this is on social network and we all are part of some kind of social networks, Facebook, Twitter, Instagram, WhatsApp, whatnot, right? And we browse social networks every day and we know how to react to certain posts, how to like, how to share, how to communicate, how to increase the friendship, how to follow somebody. But we may not know that how social networks are generally operated, right? For example, say when you wake up in the morning and start browsing your Facebook profile, you certainly see that a very interesting post. And so why that post is suddenly come to your news feed, right? For example, or your user feed. Why suddenly you see a user, right, who has been recommended by say Facebook as your friend, right? So you do not know how such things are operated, right? And these days we all have been hearing about Twitter being sold by and Elon Musk, who is the richest man in the world. He has bought Twitter, right? So what is there in Twitter that he has suddenly decided to buy Twitter, right? Why not in other company? So there is definitely something that is there in social network, and we need to understand the importance of that, right? So this course is all about understanding the importance of social network, how social networks are being operated, right? What are the fundamental properties of social networks, and how you can utilize social networks for different purposes. So before starting this course, I would acknowledge the content, some of the content that I've taken from some of the excellent courses offered all around the world. For example, courses offered by Telescopic at Stanford, courses in different Indian institutes as well. So these are some of the lists that are that I have mentioned from where I have taken different content. But of course, the list is endless. So I've just acknowledged a few, but this is endless. Okay, so I would like to thank all the content creators for creating such a wonderful course content, and based on that, I have tried to design my own course. So let me start by asking a interesting question. Might be very silly question. How many of you feel that you are part of a network, right? You may say that what is network, right? So I'm a part of Facebook. Facebook is not a network, right? What do you mean by network? In fact, if you say that you are not a part of any network, you are basically lying, right? So you are part of multiple networks, not one, right? And I'm pretty sure that when I'm delivering this lecture, or when you are hearing this lecture, you are at the same time chatting with somebody on WhatsApp, or say browsing your Facebook profile, and so on and so forth. So every time you feel some sort of inertia, some sort of attraction in one form or the others from this kind of social media, right? So if you feel that this Facebook, I mean, when I talk about social network, I only refer to Facebook or Twitter or WhatsApp or WhatsApp or Instagram. Actually not, right? I'm also referring to social network which is an offline network. For example, say for example, you are part of a community. Your friends are going to the gym at the same time, right? You are part of a music club, for example, and you are part of a college, right? You interact with your friends, your colleagues on a regular basis, right? That also forms a network, right? So when I say that social network, it can be online social network, it can also be offline social network, right? Online social network, as I mentioned, can be WhatsApp, right? You just say you are browsing an internet, right? Internet itself is a network, right? I will discuss why we call internet as a network, right? It can be a telecommunication network, for example, right? Or it can be a simple offline social network, user interaction network, right? So as I mentioned, we all are part of multiple networks, and this is a stylized example, right? For example, say, a student, right, in an university, a research scholar, for example, right? So he is a part of the department. He is part of the CS department, for example. He or she is a part of, the college. He or she is a part of the same friends club who are advised by the same advisor, for example, right, and so on and so forth. He is also part of the same family, right? So you see that multiple offline social networks also emerge where we are part of in our daily life, day-to-day basis, right? So let's start, right? So what is network? So when I say network, right, in fact, when I was in my undergrad, so when somebody said that, do you know what is network? So I feel that, I always felt that, okay, network is computer network, right? There is TCP, UDP protocols and all these protocols. Packet is being sent from one computer to another computer, one router to a computer, and so on and so forth, right? So here network doesn't mean computer network. Of course, computer network is an example of the network that we are going to talk about, but this is not the only network that we are talking about here, right? And these days when I ask a student that, what is network? So the student says that, yes, I know neural network, right? So neural network is, of course, a network, but this is not the only network that I'm talking about here. This is, of course, an example of the network that I'm talking about here, right? So then what is network? So a network is a simple abstraction of a complex system, right? What do you mean by that? What is complex system, right? Let's say our body, right? Our metabolic system, for example, right? The way proteins interact, due to different metabolic process, how neurons interact, right? How cells interact, and so on and so forth. This is a complex system. Think about internet, right? Think about World Wide Web, right? It's a gigantic system. And this is so complex that you may not be able to understand what is happening at different parts of the network, right? So this network is basically a simple way of abstracting such a complex system, right? Networks are also called as a general language for describing complex systems, right? This is, think of it as a language, right? For example, we use, say, Python or Java to as kind of a way to understand, to let the computer understand, what we are saying, right? Similarly, you think of networks as a kind of a language to understand the entire complex systems, right? If these definitions sound little vague, don't worry. I will give you a concrete definition of what is a network, okay? So now network is also called as graph, okay? Computer scientists call such structure network, whereas physicists call such structures graph, okay? They are kind of, same. Mathematicians also call this structure graph. So, but networks and graphs are basically synonymous. So, but why? So, network is the kind of network that we are talking about here. They are also called complex network. Okay. So, why it is called complexity? I mean, why it is called complex network? What's the complexity behind the network, right? So, the kind of network that I'm talking about, I'm going to talk about in this whole lecture series. So this network size is huge, right? You can think of it as, billions of nodes, trillions of edges, right? This is not as simple as, say, a star, right? Not as simple as a star like this, okay? Or not as simple as a line like this, or not as simple as, say, for example, a grid like this, right? We are talking about networks which are of billions of size, right? 1 billion say nodes, right? 1 billion edges, right? So the topological property makes this kind of network so non-trivial that we won't be able to understand the structural property of these networks by simply looking at it on blind eyes, right? This is not as simple as a structure like star or grid, right? So, a complex network consists of say nodes and edges, right? These are the two fundamental components of a network or a complex network, right, exhibiting non-trivial topological properties. Now, these terms might sound little vague. Don't worry, I will explain what do I mean by topological feature, topological structure, non-triviality and so on. That do not occur in simple network like a lattice or a random graph. Again, random graph, lattice, these terminologies may sound little vague, but we will discuss all these things, right. So, in general, when we talk about a network or when we define a network, we generally say that there is a set of nodes or vertices, right, or entities, and entities are linked through edges, right, or relations or links. As you see here in this figure, there are these circles of different colors, right. These are basically nodes or vertices, right, or individuals for example, and they are connected through different edges or links or connections, right. Now, this is the the bookish definition of a network. So, you basically define a network by a tuple of nodes and edges, and that's all, right. So, if you see this network, right, the nodes are of different colors, edges are of different colors. Why so? So, by the color, what I mean to say is that nodes can be of different types, okay. Edges can also be of different types. For example, say in social networks, say let's say Twitter, right, you can think of nodes as users, you can think of nodes as tweets, for example. Links can be a follower-following link, one is following another user. It can be a retweet link, right. Retweet link, again, it can be, I mean, you can basically connect two users using a retweet link. If somebody retweets some other's tweet, you can connect two users through this retweet link. In fact, between a tweet and a user, you can also connect, right, through say something called posting, right. If a user has posted a tweet, you can connect these two entities, right. So, nodes can be of different types, edges can also be of different types. Nodes can have properties, right. For example, users, you can characterize a user based on his or her occupation, right, the location, right, the gender, the race, and so on and so forth. You can also characterize edges in different ways. We will talk about all these things in this lecture. So, but what I wanted to say is here is that when I talk about a network, don't think that nodes are of same type or edges can be of same type. It can be they can be different. Edges can be different. Nodes can be different, right? So, if you look at networks or the complex networks, right, the position of this particular subject, right, you see that it basically falls at the intersection of say machine learning, data mining, or statistics, and some sort of algorithms, computer systems, and so on and so forth. So, throughout this lecture, we will see that a lot of data mining techniques are being used on a regular basis to understand the properties of a network, right. We will use whole bunch of statistics to understand the properties, right. We will use algorithms to understand the different tools or different applications that people use these days based on this network, and of course you can design real world systems based on the analysis of the network. So, all these branches are important to understand complex networks or networks in general, right. So, let us now look at the definition. We have already discussed that a network is defined by an ordered pair G, V, comma E, where V is a set of nodes or vertices and E is a set of edges or links, right. Now, depending on the topological structure of the network, you can think of two different types of networks. The network can be of undirected type. For example, right, there is no direction of edge, right, between two nodes. For example, if you see say this network, you see here nodes are connected, but edges do not have any direction, right? Example, if you think of, say, friendship network on Facebook, right? There is no direction, because if I am a friend of a person, right, a person X, X is also a friend of mine, right? This is basically bidirectional, right? And bidirectional is equivalent to unidirectional edge, undirected edge, right? Similarly, a network can be of directed in nature. So edges can have directions, right? For example, follower-followee network, where if I follow person X, it is not necessary that X will also follow me. So you can see a direction from, say, from Y to X, right? But as you see here, X is not following Y, so there is no opposite direction like this. Okay. Again, it all depends upon how you basically model a particular complex system. So Twitter in this case is a complex system, or Facebook in this case is a complex system, right? Even you can think of something called hyperedge. This is even a more broader version. I mean, a kind of a generic way of defining a network. Okay, we will discuss what is hyperedge, hypergraph later. Okay, nodes and edges can be of can have attributes, as I mentioned earlier, right? Edges can also have weights. Now these weights, you can think of weights as the strength of an edge, right? Say for example, if two users are interacting very frequently, right? You can think of the edge connecting these two users as having higher weights, right? So as you see here in this particular example, all the edges have some sort of weights, right? Weights are positive, but of course depending upon the application, you can think of negative weights as well. Okay, edges can also have timestamps, right? For example, again, follower-followee network. Say I have already followed another user X at timestamp T1. I am following user Y at timestamp T2. So this T1, T2, these are basically timestamps associated with edges. Okay, edges can also have features, right? And when we talk about these kind of graphs or networks, right? Some of you may have learned graph theory, the basic graph theory, although this is not that needed, right? But it is always good to brush up some of the skills on graph theory. For example, you have heard about something called self loop, right? What is self loop? Self loop is basically an edge which starts from say node X and also ends at node X, right? So the starting vertex and the ending vertex, they are all same. As you see here, this edge, this is basically a self loop, right? You can also have parallel edges. Parallel edges meaning, say there are two nodes and there are two edges or say three edges connecting these two nodes, right? And this is possible. Again, let's say Twitter network, right? Say one edge indicating follower-followee, another edge indicating retweet, right? Whether X has retweeted Y's tweet. Another edge say indicates whether this user has liked some of the post of user Y and so on and so forth, right? So, but when we talk about network, we generally avoid such graphs where self loop and parallel edges are there, right? So when I say that, let's say a network G, right, V comma E, I will assume that self loop and parallel edges are not available. If needed, I will explicitly mention that these two things are available. Okay. So, right. So we have discussed what is a network, but this course is about social network, right? So what is social network? So network is an abstraction of a complex system. Social network is a simplified representation of a social structure, right, between users, among users. It can be online social network, offline social network. And what is social network analysis? This is basically an application of networks and graph theory to analyze the relations present in a society, right? A society can be online society or offline society. Okay, now this is an example of a very tiny portion of a Twitter network. This is not at all the Twitter network these days, right? But this is a portion of Twitter network. As you see here, nodes are indicated by different users. You see here bill grades and different dignitaries you also see, normal users like us, right? And all these links are present between users, right? Some, if you look at here, Bill Gates, right? A lot of pages are connected with this node, right? Whereas user like this one, right? Or user like this one, there are 3-4 edges connected with this node, right? So we will understand, we will analyze, how this kind of network is formed, right? How do we characterize nodes based on these edges, and so on. Now let's look at the applications, some of the important applications that we can think of. So, the first and foremost application is healthcare. This is of our priority because of, the kind of pandemic through which we are going. So, you can actually use social network analysis to understand or to model different things. For example, we can understand how, how an infectious disease actually spreads, in our society, right? We can actually model it. I'm pretty sure you have heard about many such models, the data-driven models, which basically try to mimic the way, say, COVID-19 virus spreads, right? You may also have heard about Ebola, for example, right? And people basically modeled how this kind of virus spread over, offline network, right? We'll also talk about, say, if we understand how such things spread, you can also come up with policies. For example, lockdown policy, right? We can't afford unlimited lockdown. So what would be the typical lockdown policy that a government should take to stop the spread of the virus, right? In fact, if the vaccine is available, how do you efficiently or effectively vaccinate people so that the virus is not able to spread from one part of the network to the other part of the network, one part of the society to the other part, right? Whole bunch of things can be possible through social network analysis, and we'll discuss about this in a separate chapter altogether. Okay. Of course, social media is an important part where social network analysis is important. For example, in Facebook, Twitter kind of setting, friendship recommendation, follower recommendation, right? All these things, how information spreads, say for example, misinformation, fake news spreads over social network. How can we understand the pattern? How can we come up with techniques to stop the spread, and so on and so forth. These things are also will be discussed in the subsequent chapters. E-commerce service, another important application, right? We have seen like applications, we have seen e-commerce services like Amazon, Flipkart, right? eBay, where products are being recommended to users, right? Say for example, if you buy a mobile, right, you will be also recommended to buy, say, a headphone, right? If you buy a laptop, you will be also recommended to buy a mouse, for example, right? So you may wonder why, right? You may wonder why these items are being recommended, right, to me, right? In fact, it is also possible that you suddenly wake up and see that some very weird item is recommended to you. So you feel that, well, I have never seen this product before, but why suddenly this is recommended, right? You may be surprised to hear that all the users are being tracked, right, who are basically browsing e-commerce services, and depending upon their buying pattern, the way they browse through the e-commerce services, right, the clicking patterns, everything are being analyzed in a systematic way, and based on that you are recommended products. Again, we will discuss this kind of recommendation systems, right, in general in all the chapters. Web search optimization. Web in general is a massive network, right? I mentioned World Wide Web, right? So there are web pages. Web pages are linked through hyperlinks, right? When you open a web page, you see there are many hyperlinks. You can basically click on one hyperlink, you move to another web page, and so on and so forth. So the entire web pages and their links through hyperlink, this is basically a network, right? And how do you know the importance of a web page, right? It all depends on how we browse through different pages, right? How we click on a particular page, how we move from one page to another page. We will discuss an algorithm called PageRank, which was responsible for, for a creation of a company like Google, right, way back 1998, 1999, when this PageRank algorithm was proposed, was published, and company like Google was formed based on the simple idea. Okay. And this is very interesting. You can also analyze, how criminals, how terrorists, interact, how terrorists recruit, how criminals recruit, new individuals, right, through social network. In fact, there is a very interesting study which actually said that if we had analyzed social network before, we could have stopped the 9/11 attack, right? And that was really, terrible finding, right? So we can also think of, detecting fraud users, for example, right? Fake news, cyberbullying, all sorts of, online harms through social network analysis, right? Social network is also useful for scientific research mining, right? Let's say you have whole bunch of scientific articles or patents, right? Papers, journals, conference papers, right? Available. How do you mine such data sets, right? You can also think of a network out of it, where nodes can be scientific papers, scientific articles, and links, and these nodes can be connected through citations, for example, right? Citations between papers. So say paper X is citing paper Y. This is definitely a directed network, as you can imagine, right? And if you know the citation network, you can do, you can unfold whole bunch of things. For example, you can see how a knowledge basically propagates from one community to another community, how such an interdisciplinary field emerges, over time, how two fundamental, communities, for example, say AI and say, database, right, for example, interact through citations, and, and that leads to an emergence of another new field altogether. You can also track, a scientific field of a particular user. Let's say you have a successful researcher, you have not so successful researcher. If you look at the career trajectory of both these researchers, you will see a clear trend, that how two researchers publish their papers, which communities, right, what are their citation patterns, and so on and so forth. And based on that, you can do a whole bunch of things. Each index, imperfecta, these are of course dependent on citations, but if you have the citation network, it will give you a holistic view of the publication data set in general, right? So citation network is something which is very important. And another network you can also create out of this publication data set is something called co-authorship network, where nodes are researchers, and two researchers are connected when they wrote a paper together, for example, or they filed a patent together, right? So in this co-authorship network, this is also called collaboration network, you can also see, different communities. You can clearly see that, a physics community and a, computer science community, they do not often interact, right? But sometimes when they interact, they create magic, right? For example. So whole bunch of things can be possible if you model this scientific publication data sets through networks, right? So in the next lecture, I will try to give you more motivation, more applications behind network science, social network analysis in general, and hopefully I'll be able to convince you why this is an important course altogether. Thank you.